I'm an educator. That falls under fair use. Grumble, grumble. Grumble, grumble. All right. And there we go. All right. So we're going to start by talking about memory today. All right. So we are going to start by talking about some really basic concepts when it comes to memory. So we're going to start by covering this. So we're going to talk about what memory is. We're going to talk about why it's important. We're going to talk about some of the general properties of memory. We'll talk about how memories are built, how we make them. We're going to talk about why we forget. I'm actually going to be recording a special video on amnesia and forgetting later this afternoon. And I would say have a scratch piece of paper handy when you watch that. I'm going to ask you to draw pictures. We're going to talk about memory construction. And in the textbook, I will talk a little bit about how you can improve your memory. And I was going to say, if you've ever had any questions about memory, this is absolutely the lecture to ask on. This is my area. I am a short-term memory researcher. I can absolutely answer any questions that you have on this. Okay, so first, before we do anything else, I want to talk a little bit about this quote. You do not need to write this down. So this is an autobiography from Eric Kandel. Now, for those of you who probably don't know who Eric Kandel is very well known for looking at memory and the neurobiology of memory and the cellular basis for memory. In your book calls them sea slugs, but technically they are soft shell, they are shellless sea snails. And he's one of the first people to actually find that memory has a cellular basis. If you are interested in learning more about this cellular basis of memory, you can take my biopsych class next semester where I talk about this in great detail. But this is basically his autobiography. He's also, if you ever take a neuroscience class, especially in graduate school, he has like a textbook that is this thick. And when I was in graduate school, I lugged that textbook 30 minutes from one end of campus to the other just to get to the bio building. I built some muscle that semester. But I really like this quote. Without the mental time travel provided by memory, we would have no awareness of our personal history, no way of remembering the joys that serve as the luminous milestones of our life. We are who we are because of what we learn and what we remember. And I think that that is 100% true. Everything that you are, everything you know about yourself, you know because of memory. So many of you have probably experienced, how many of you here in class, or those of you who are zooming in, how many of you have somebody that you know that has Alzheimer's disease? Okay, so we have a couple of hands going up. Let me check our chat. Okay, so a few people do. I have two grandparents. One passed away last year after a 15-year battle with Alzheimer's disease, and my grandfather has it right now as well. And I'm sorry, Trinidad. One of the things that's really hard about watching somebody with Alzheimer's disease is that they not only lose their memory, they lose a sense of who they are. And that is very, very difficult to watch. Memory makes us who we are. And that's why I think it's so important. So, because it's Monday and because I'm not very nice, actually I'm very nice, but sometimes I make you do things that are not very nice. We're going to do a little memory test. So I'm going to read you a list of words. And then as soon as I tell you to, I want you to recall as many of them as you can in any order that you want. They are not going to be related to each other. This is not a false memory study. So are you ready? Is everybody ready? All right, so here's the list. 9, swap, sell, ring, lust, plugs, lamp, apple, table, sway, army, bank, fire, hold, worm, clock, horse, color, baby, sword, desk, grab, find, bird, rock. Write down as many words as you can remember. If you can't remember any, just leave it blank. No judgment. But there are a lot of words on that list. You should be able to remember at least one. We got 3. Okay. Baby sword. Okay. All right. So I'm going to trust that if you remembered something, it was on the list. So go ahead and raise your hand. I'm just picturing an army of babies with swords. I hope they're plastic for the sake of the babies. So go ahead, and I can kind of see on the chat, most people are recalling maybe about 3, 4, 5. How many of you that wrote things down on paper? How many of you recalled at least 5? 6, 7, 8, 9, maybe 10, 11, 12, 13. You got 13? Nicely done. Okay, so hold on to that list because we're going to talk about it later. So hold on to that. Okay, so what is memory? Let's talk about what memory is in light of what you just did. So memory is your ability to store, to hold on to, and then later recall that information. And memory researchers like myself have really special names that we use for these processes. So when you are trying to remember things, when you're trying to remember something for later, and let's just get a quick show in the chat and on Discord. How many of you tried to repeat the list items to yourself as you were hearing them? A few of you. Okay. All right. Oh, it did? Okay. So this is what we call encoding. So encoding is basically when you try to make sure that you can remember something for later. When you are holding on to that information for use at a later date, we call that storage. And then finally, the actual act of remembering is what we refer to as retrieval. So we have encoding, we have storage, and we have retrieval. And later this afternoon, I'm going to share a video that talks about how forgetting can occur at every single one of these stages. So we can have forgetting due to a failure to encode. We can have forgetting due to storage. Information decays over time. Information becomes fuzzier over time. We can also talk about a retrieval failure. How many of you have had instances where you've tried to remember something and you feel like you have it and it's on the tip of your tongue, but you can't quite name it? That is what we would call a retrieval failure, because it's somewhere in your memory, but other items are competing with it. All right, let's see. Literally every day. So why is memory so important? I would argue that memory is important because it is involved in literally everything we do. You have a memory of language. You have a working knowledge of language. If you had no memory, odds are pretty good you would not be able to understand what I'm saying. If you had no muscle memory or knowledge of how to move your hand, you would not be capable of writing words and taking notes. And if you had no memory, you would not have a sense of who you are as a person. You wouldn't know how to get to campus. You wouldn't know how to get into this building, and you certainly wouldn't remember your assigned seating. So I'd be like holding up the seating chart, like, no, you sit over here. So memory is involved in everything, and it does give us our sense of self and our personality, because we remember the consistent ways in which we behave. All right, so let's start by talking about some of the general properties of memory. So we're going to talk about different types of memory. And one of the things that we're going to find is, despite the fact that these different types of memory do in fact differ from each other, they do share some really important commonalities. So one of the first things that we're going to talk about is, number one, memories have different durations. So we are going to talk about 3 different types of memory based on their duration. So I want you to kind of imagine this. Every day when you're out in the world, you are getting a variety of different information from the environment. That's all based on your sensory experiences. You're getting smells, you're getting sights, you're getting sounds, you're getting tastes, you're getting touch. So you get all of this information from the environment. Now, here is my question. Can you pay attention to everything in the environment? Probably not. But odds are pretty good that some of the things that are going on in the environment, you need to pay attention to. So if you're driving in your car, there's a lot of visual stimuli going on, but if somebody darts out in front of your car, that's information that you need to hold on to. That's information you need to pay attention to. And so some of this information we are going to pay attention to, and this is what is known as sensory memory. So sensory memory is designed to help us track changes in our environment. So there's a really easy way to kind of see your sensory memory, and we'll talk more about sensory memory in a little bit. How many of you did this when you were a kid? I do it all the time, even now. I'm not ashamed to admit it. How many of you did this where you make the pencil look kind of wobbly by shaking it? The reason that that has that wobbly appearance is because of your sensory memory. Your brain briefly keeps track of where the pen was before, and it's keeping track of where the pen was now. And because of that, it creates a wobbly appearance. Another way that you can see your sensory memory is by playing with sparklers. So a sparkler is just one little point of light, but if you trace it very quickly, you can make shapes. You can see your sensory memory because it's keeping track of the line that you are making with those sparklers. But what do we know about those shapes? What happens as soon as you're done tracing a heart with the sparkler? What happens to the heart? It fades. So one of the things that we know about sensory memory, and we'll talk about how we know this, it holds a large amount of information, and it needs to. You need to be able to keep track of visual changes as you move through your environment. You also need to retain a sense of continuity. You also need to keep track of what somebody is telling you. So that's true for speech and for auditory information as well. So it holds a lot of information, but it's very, very short. Its duration is less than a second. In the case of auditory information, it's probably closer to 2 seconds, but that's still pretty short. Now, some of this information in the environment, you're going to need to pay attention to and remember for later. If we pay attention to information in our sensory memory, then that information goes to another store called short-term memory. Now, I want to be really clear about what short-term memory is and what it isn't. So I like to tell people I'm a short-term memory researcher. And usually when I tell people this, they go, oh, you need to help me out. I don't remember what I had for breakfast yesterday. And that's when I become the, well, actually person. I become that person. I'm like, actually, what you had for breakfast yesterday is actually your long-term memory. Your short-term memory is what you are currently paying attention to right now. And that's only about 2 to 30 seconds, give or take. Now, some of this information that you're currently paying attention to, you may not need for later, but some of it you might. One other thing that I will mention about short-term memory, because it's based on what you can pay attention to, it's very limited in number. Some people have said it's about 5 to 7 items. I would actually argue that it's closer to about 4. So if we need to remember something for later, we're going to try to repeat it to ourselves or find some way to make it meaningful to us. And then we're going to access long-term memory. Now you'll notice I don't have a duration here. So why don't I have a duration listed for long-term memory? Anybody have any thoughts? How so? Okay, so, well, I think you're kind of hitting on the idea that some memories can last your entire lifetime. Now, of course, our lifetimes are going to vary, but memories can be, in long-term memory, they can be a few minutes old, all the way up to decades old. So there's not necessarily a time limit for long-term memory. There's not a duration. Additionally, there's not necessarily a capacity limit. How would we even be able to study how many long-term memories you have? Basically, what you can say is that long-term memory has a very long duration, and it has potentially an infinite capacity limit, or at least as much as your brain will allow. So when I talk about a model like this is actually probably one of the best known models of memory developed by Atkinson and Shiffrin in 1968. This is what is called the multi-store model. So we have sensory memory. We pay attention to that information. It gains access to the short-term memory. We try to rehearse that information or make it meaningful, and it gains access to long-term memory. You don't have to worry about these bottom arrows. This is how information is lost. We will talk about that in our forgetting section that I'll film later this afternoon. Now, this is not the only model out there. There are other models. There are actually researchers who believe that long-term memory and short-term memory are not actually separate from each other. I think that's cute, but I don't think it's correct. Like, you can say that, but I don't think it's correct. And they have their reasons, and I have my reasons for believing that they're separate. But this is probably one of the easiest models for students to understand, which is why we keep using it. All right, does anybody need some more time here? Okay, so I mentioned sensory memory. So sensory memory, technically, we have a sensory memory for every sense. So this technically means that we have a sensory memory for sight, we have a sensory memory for hearing, we have a sensory memory for touch and taste and smell. Having said all of that, generally, we mostly do research on sight and hearing, and to a lesser extent, touch. We don't really talk about sensory memory for smells or for taste. So probably the best known work on sensory memory is on our visual sensory memory. And this is what is referred to as iconic sensory memory. So this is a momentary sensory memory of visual stimuli, and it has a really short duration. We are talking about 1/3 of a second. So that's 300 milliseconds. So how do we know about iconic memory? We know about iconic memory because of a very famous experiment that was done in 1960 by George Sperling. And I made the cognitive students do it a couple of weeks ago. They hated me. It's really hard. All right, does anybody need some more time here? Okay, so here's the basic experiment. So he presented participants with an array of letters, just like these. And depending on the circumstances, they had to recall in different sorts of ways. So Sperling first did what is called a whole report procedure. So basically what the participants had to do is they looked at this array of letters, and then they had to recall as many letters as they saw as possible when this briefly flashed on the screen. And by the way, this array was presented incredibly quickly, less than 1 second. I think in the experiment that I did with the cognitive class, the array was presented for 100 milliseconds. That is 1/10 of a second. And you think you wouldn't be able to see anything, but you can, but you're not going to be able to grab all of them. So you grab as many items as you can from any row or column. And Sperling found that when he did this, people tend to recall about 4 or 5 items. And the data from my cognitive class actually kind of match that. So the letters are displayed on a screen. Oh, did you need me to go back?
No, it's just more like, don't they do that with like, is it like chimpanzees? Like they do this kind of experiment on chimpanzees to see how fast they're going to move?
I can actually show you that in a little bit. So for those who didn't hear, Thalia is talking about a very famous study of a chimpanzee named Ayumu. And what they do, I think this is the experiment. They present monkeys with these random digits on a grid, and they have to press the items in order from 1 through 12, digits 1 through 12. But as soon as the chimpanzee presses number 1, all of the items basically become masked, so they're hidden. So they have to rely on their memory for where all of those digits are. And if you watch a chimpanzee, this particular chimpanzee, Ayumu, compared to a human, it's bad. I will share a link with you to this. And maybe on Wednesday, I will tell you a very funny story about how my lab, when I was in grad school, how we tried to replicate that experiment. We basically pretended to be chimps.
Okay.
Yeah, and if you watch this video, it will make you feel really bad about yourself. Please don't. It is a species specific thing. Chimpanzees need to do things that you do not, and you do things that chimpanzees do not need to do. So of course, your memory abilities are going to be a little different. But I think I know, is that the one?
I think so, yeah.
Okay. So here is the very famous experiment. So we display letters on a screen for about 1/20th of a second. The screen then goes blank. Now here is where the experiment took a turn. So after doing that whole report procedure, Sperling then changed the rules. He said, okay, I'm going to play a tone after the letters disappear. If it's a high-pitched tone, beep, you have to recall the top row. If it's a medium pitch row, beep, you have to recall the middle row. If it's a low pitch tone, beep, I can't even get that low. You have to recall the bottom row. So here's what's really critical here. You don't have to recall the entire array, you just have to recall the row that is cued. And you don't know ahead of time which row you are going to get with this partial report procedure. So here's what's really interesting. You have to recall the letters in the row indicated by the tone. People were able to recall the entire row, no matter what row was cued. They didn't know what they were going to get ahead of time, but they were capable of reporting the entire array or the entire row if it was cued quickly enough. So here's what Sperling thinks that means. If you don't know what you're going to get ahead of time and you're able to recall the whole row when cued, it could have been any row and you would have been able to recall it. So Sperling reasoned that if you present that tone quickly enough, people are able to hold the entire array in their visual sensory memory. So all of the array is available for a very short time. So what he found is that sensory memory has a very, very short duration, but it has a very large capacity. All of the array was available, but the timing of when that cue was presented matters. So if you presented the cue almost immediately after the array disappeared, people were capable of recalling the whole row. If you presented the cue, that tone, up to a second after the array disappeared, they could maybe only recall one item if they were lucky from that row. So Sperling found that the memory for the visual image actually fades after about 1/3 of a second. So your visual sensory memory is basically limited to about 300 milliseconds of duration. Now we do also have echoic memory, but I'm not really going to talk about that very much. And echoic memory tends to have a slightly longer duration because it's based on speech. So this is a momentary sensory memory of auditory stimuli. And we need to be able to have some auditory sensory memory because when you're talking, you need to be able to remember the last few seconds of speech sounds that somebody has made to be able to understand what they're saying. And maybe you've had this experience where you're in school and you're not really paying attention, and your teacher will suddenly be like, are you listening to me? And you're able to repeat back the most recent thing that the teacher said, even though you're not actually paying attention to it. How many of you have had that experience? A few of you. So that kind of shows a little bit of how echoic memory works. Okay, so let's talk a little bit about short-term memory. So short-term memory briefly holds a small number of items in mind for a very, very short time. According to Miller, based off of some work that he did in 1956, short-term memory appears to be limited between 5 and 9 items. So in 1956, he presented a paper to a conference of the Eastern Psychological Association that was basically a huge review article that found that short-term memory is limited to about 7 items, plus or minus 2. And that's actually the title of the paper. It's called The Magical Number 7 plus or minus 2. Now, here's what's kind of interesting. More recently, especially in about the past 30 years or so, we actually think of that as being an overestimation. So I need somebody to help me out. And I want somebody from Zoom to help me out. You are going to have to turn your mic on. So I need somebody brave, and I need someone who likes Disney.
Me, I like Disney.
Okay, okay. So I heard Aaron and I heard D Finley. All right, so I'll start with Aaron and then we'll go with D. Aaron, here's what I want you to do. I want you to name all of the 7 dwarves in Snow White.
Oh, dang.
Give it a shot.
Okay. All right. There's isn't it Grumpy? Sneezy? No, I don't think that's right. Sleepy. Okay, hold on. Okay, Grumpy, Sleepy. I was just watching Descendants. I know this. Is there Happy? I think that's right. Happy. I'm gonna cry.
It's okay. I'm not actually interested in whether you get all 7 correct. I'm not. But hold on to that. And for those of you who were listening to her recall that, pay attention. Dee, do you want to give it a try?
Yes, I know this.
Okay, let's hear it.
There's Sneezy, Sleepy, Doc, Happy, Dopey, and Grumpy.
Yeah, but that's 6. You forgot one. It's Bashful, by the way.
Bashful, okay.
Okay, so here's something kind of interesting, and I want to go back to Aaron. By the way, thank you very much, both of you. I will give a hand for your assistance. You can go ahead and mute yourselves now. So here's what I think is really interesting, and I'm going to pick on Erin's recall. Not because she recalled so few, that's not the issue. What I was interested in, how many of you noticed that she recalled the first 3, and then she took a really long pause? So here's what's kind of interesting. So this is based off of research by somebody named Donald Broadbent. And he actually went up to people and asked them to remember 7 items that people tend to remember pretty well, like the 7 continents of the earth. People remember that very, very well. Here's what he noticed though. People tend to take a long pause between recall of the 3rd or the 4th item. Now here's his point. If you can hold 7 items in short-term memory, there should not be a pause, right? Now we know why that pause is happening. You're pausing because you're searching through your long-term memory trying to find it. But if your short-term memory can hold 7 items, you wouldn't need to do that. So research has actually confirmed that when you prevent people from using strategies or having to retrieve from long-term memory, short-term memory is actually closer to about 3 or 4 items. So my doctoral advisor actually wrote a paper about 20 years ago looking at this topic, and it's actually referred to as the magical number 4 plus or minus 1. So regardless of whether we talk about Miller's idea or this idea that Miller's number is an overestimation, that's still pretty limited. 7 items is still pretty small. 4 items is especially small. And there are occasionally people who think you can only hold 1. They're wrong, but okay. My doctoral dissertation looked at that. I'm kidding. We're allowed to have different ideas. But also, we do tend to find that short-term memory has a very short duration of typically no more than about 30 seconds. So what you're looking at here is a famous study by Peterson and Peterson in 1959. People were given lists of consonants, and then under certain circumstances, they were prevented from rehearsing or repeating those items to themselves. So basically, they had to spend a certain amount of time counting backwards by 3s, because we like doing that. They either had to count backwards by 3s for 3 seconds, 6, 9, 12, 15, or 18 seconds. And you can kind of see that the longer that retention interval is, the worse that memory for those consonants becomes. So you can see that by the time 9 seconds is reached, only about a little more than 20% of the information was remembered. By the time 18 seconds has lapsed, you're out. So short-term memory has a small capacity and a short duration as well. Now, as of 1974, we actually occasionally will refer to short-term memory as something called working memory. And I'm going to keep this pretty brief because I talk a lot more about working memory and cognitive psych, and you really won't need to know too much about it here. But typically how short-term memory has been conceived of in the past is that it's just a storage buffer. It's a temporary area where information is held. And basically with short-term memory, it was believed that one of 2 things happen. Either you try to rehearse that information and it goes into long-term memory, or information is eventually dropped from short-term memory and is lost forever. So here's what's really critical. Short-term memory was treated like a little passive storage buffer, and you couldn't actually manipulate or transform or modify information if it's in short-term memory. Research actually shows that that is not true. You can actually manipulate information in short-term memory, and you can also link it with long-term memory, which the original multi-store model does not have. And so because of this, as of about 1974, we have this concept of working memory in place of short-term memory. So this is an area that basically stores and manipulates visual information, speech-based information, and also can link that information to long-term memory. That's really all I might ask you about working memory. I will be as brief about it in the testing materials as your textbook is. Okay, so we already recalled items from those lists. So I want to go back to the items that you remembered. Now, I saw quite a few people remembering baby and sword. Here's what I'd like you to do. If you're zooming in, drop in on the chat. If you're here in class, raise your hand. How many of you recalled any of the following items? Raise your hand if you recalled at least one of them. 9, swap, sell, ring, or lust. Okay. Everybody here in the classroom has their hand raised. Let me take a look over here. We have a couple of people who recalled. Trinidad did, Lightness did, Evie did. Let me see. Apple Rock, Baby Sword, Army. Okay, now how many of you recalled the following items? You can put your hands down. How many of you, yep, okay, good. How many of you recalled one of the following words? Desk, grab, find, bird, or rock? Quite a few hands here as well. Okay, good, good. Now, here's another question. How many of you recalled hold, worm, clock, or horse? Okay, less people. So here's what's kind of interesting. When we recall information from lists like this, we tend to remember the first items of a list really, really well. We tend to remember the last items of a list really, really well, and we tend to tank out in the middle. We will talk about that very soon, but it looks like for most of you, that demonstration showed that as well. So when we talk about what you did to try to remember those list items, you engaged in what was known as effortful processing. But remember that we have a dual track mind. Remember that your book is always talking about the importance of dual processing. And there are some things that you do that are automatic. So for example, have any of you noticed that there are certain words that I tend to use when I talk a lot? Or have you noticed that some of your professors have certain verbal tics? So I had a professor in graduate school who would always go, "What else hit you?" all the time. And I loved it. And I don't even think he was aware of doing it. I have a tendency to use the word actually or basically. And a phrase you've probably heard me say a lot is take it with a huge grain of salt. So if you are able to note that there are words that I use more, it's not like you were actively trying to remember that. That is automatic processing, and it does not require your conscious awareness. So here's what's interesting. If you have a fight with a friend, generally you can remember where you were when it happened. So what area, maybe you were in the dorm, maybe you were in a classroom. So you can remember the space that you were in, and you might remember the time of day. But that's not something that you are actively trying to remember. Your brain automatically encodes that for you. So you can notice things like space, so spatial location, time, or frequency. And it can be really difficult to shut those off. So here's an example. So for those of you that are new and you're here on campus, do you remember navigating and trying to find your way to RBAC and try to find your classroom the first day of classes? Remember how hard that was? Now I want you to think about the fact that you came to class today, or you've come to a classroom and you don't even think about it much at all. Now, were you actively trying to remember the exact directions you took to get to the building? No. You were forming that cognitive map that we talked about in in chapter 6, but that's not something you are consciously doing. It is something you do automatically. Now, when you're trying to remember a list of words that I give you, you're engaging in effortful processing. This requires your conscious attention. Typically, this will happen with information that is new or uninteresting, or any time that you are learning a new skill. And we kind of talked about this before, like the first time you ever tried to drive a car. Many of us apparently confused our gas and our brake. But over time and with practice, that becomes more automatic over time. But initially, it's very effortful. Rehearsal may be required. You might have to actually study information to remember it. I know, right? That's quite a hot take. Sometimes you have to study something to remember it. Who would have thought? And rehearsal is when you are consciously repeating information. So I want to go back to that list you had to recall. Was this anybody else's experience when they were trying to remember the items? So the first few items you might have repeated to yourself. So our first word was 9. So maybe you went 9, 9, 9. And then you got 9 and then swap. And then you went 9, swap, 9, swap. A lot of people do this. Now, at some point, you were juggling too many items, weren't you? And so what ends up happening is that people, when they have too many items they have to rehearse, it's like they're juggling all of these items and they're finally like, they throw all the items up in the air. I'm like, I can't do this anymore. I'm just gonna listen. And what we end up tending to find is that because you rehearsed those items, those first few items, they're in long-term memory. You'll remember them. But once you throw all of the balls that you're juggling into the air, that's usually around the middle of the list. And because of that, you tend to remember those items not as well. For items that are at the end of the list, that's because of your short-term memory grabbing onto those last few items. So that's why your recall of a list often looks the way it does. So I hate to break it to you folks. This is our last slide because it's 10:35. The clock is a little slow. But the total time hypothesis, your memory depends on learning. I hate to break it to you. You will not learn this information in this class or in any other class by putting a textbook under your pillow and hoping that all of the information magically enters your mind. It's not going to happen. You actively have to study it. So we're going to talk about this next time, but generally, the more that you study something, the better your memory for it is going to be. I was joking that it's a hot take. It's really not. It's backed up by research. You actively have to study something if you want to remember it. And we'll talk about a famous researcher who found this out next time because he basically experimented on himself. So now I am a minute over. I'm sorry. And so have a great day, folks. I will see you next time. And we will talk some more about memory then.